So this video is intended to give you some tips and tricks that you can use for making a spreadsheet in Excel that does all your calculations for the experiment. So what you're looking at right now is a template spreadsheet for the acceleration on an incline experiment. Your lab instructor may or may not give you a template spreadsheet, but even if they don't worry about it, because although this looks fancy, it's a completely empty spreadsheet, except for labels. So you would still type in all of your data, and you type in all the formulas that would allow Excel to calculate your final values for you. So regardless of whether you've got a template spreadsheet or just making your own, you're still going to be doing all the brainy stuff. So just to give you a little tour of what you're seeing, up here at the top, there's a section labeled Measurements. So this is where you would type all of your raw data that you recorded in your lab notebook. And then down below, there's another section labeled Calculations. So this is where you do all your calculations to get your final values from your measured data. So calculations at the bottom, raw data at the top. And there's one thing I'll just point out right now. Right here, for example, we've got the distance that the cart moved. And if I go down, I see it again, distance that the cart moved. So why is it in both locations? Well, the units down here are meters, and the units up here are centimeters. And what this is meant to imply is that we do want you to do conversions in Excel. So the first thing you would want to do with your spreadsheet, after you've got labels typed in, is then type in all of your data from your lab notebook. So I'll use a bit of video trickery to do that now. So there's my raw data added, and now I'm going to zoom in just a little bit so you can see what I'm doing better. So I want to draw your attention first to the fact that I've got this third column of data on every single type of data. So what are these? Well, I've got my value, and right beside it I've got the uncertainty, and then the third column is the fractional uncertainty. You should put this on every one of your pieces of data for two reasons. The first is that when you're doing your discussion in your typed report, you're going to need to talk about something called precision, and the fractional uncertainties are super useful for doing that. The second thing is that when you're typing in more complicated uncertainty expressions, you often need your fractional uncertainty. So let me do this calculation now. So the formula would be equal sign, the uncertainty, divided by the value. Hit enter, and it gives me my number, and now I can copy and paste this downward. Of course, the thing is, I'm going to need to do that same calculation all over the spreadsheet. It's everywhere. And there is a way to do them all at once with a copy and paste. So the trick is that you need to know about how to do a multiple selection. What I mean is, right now, I've clicked on this cell, I've selected it. If I hold down my Control key, I can now select a bunch of other stuff, as many things as I want. So we're going to use this to take one of these formulas and then copy it everywhere in the spreadsheet. So I'm going to zoom out again to show you how to do that. So now I'm zoomed out, and I'm going to make sure I'm clicked on one of these cells that has that formula in it, and just to double click, it only refers to the two cells right side by side, which means I can copy and paste this formula anywhere in the spreadsheet where the data is arranged like that. So I click on this cell, I go up to the clipboard, and I click on copy. Now it's got that blinking outline, and now I'm going to use my multiple select trick. So I click on some other cell where I want to paste that function. I hold down the Control key, and then I can start clicking everywhere else I need to have a fractional uncertainty. And in fact, I've got some on the bottom here as well. And I believe that's all of them. So now I can go back to the clipboard area and just click Paste, and it fills in all of the functions for me. So these ones up here, where I already had data filled in, they came out correctly. These ones down here, where there's no number, are going to be an error message for now, but they will fix themselves once I have values in these two cells. So now I can start doing some more calculations. I'm going to start by doing these averages down here and their uncertainties. So again, I'll zoom in for that. Okay, so I want to calculate the average of all of these acceleration values, and Excel has a function for that. So I type equals average, open bracket, and then highlight my list of data. It fills in the values for me. Close the bracket on average, hit enter, and it gives me my number. And of course, I can use my multiple select trick here as well. So I can click that cell, click copy, click another cell, hold down Control, and click the third one where I want an average to happen, and then click paste. So those are filled in now. Great. So next, I want to do the uncertainty on the average. Now remember, the uncertainty on an averaged value has nothing to do with these values up here. Instead, we're going to use the statistical uncertainty. So just as a reminder, this is the formula for it. So I click equal sign, 2, asterisk for times, and then I want the standard deviation of all of my data values. So ST, DEV, open bracket. Then I highlight all of my data values. And remember, I'm highlighting the data, not the uncertainties. So standard deviation is a measure of how much these data values vary relative to one another. Again, standard deviation has nothing to do with the individual uncertainties on each data point. Close the brackets on the standard deviation, divide by SQRT for the square root, open the bracket, and now n is equal to 10 because I've got 10 data values here. But you don't actually have to remember that fact because Excel can count up how many values there are. So there is also a function called count, open bracket, and if I highlight all of my data again, it's going to count how many data points there were in there. Close the bracket on count, close the bracket on the square root, hit enter, and it has calculated the uncertainty of the average. So again, I can copy and paste this sideways because these two formulas over here should be exactly the same. So I click on the cell, click copy, click one of these, hold down Control, click the other, and paste. And now I'm done calculating my average values and their uncertainties. So now let's go do our conversions. So if I come over here, I see a bunch of raw data, and if I come straight down from those, there's some of these things that I have to convert to new units, or in the case of the height, to do a simple calculation. So let me do those now, but I'm going to zoom out a little bit because that'll help you see what's going on. So up here, the distance d is in centimeters, and down here, I need to convert it to meters. So to do that, I type equals, click this value to fill in that cell address, divide by 100, hit enter, it's now converted for me. So we do want you to do an explicit calculation like that. And because the uncertainty is going to be converted the same way, I can just click and drag sideways to convert that value also. Then I also need to convert this value, so equal sign, length, divide by 100, hit enter, copy and paste that function sideways to also convert the uncertainty. Now the track height is going to be the difference between this value and this value. So I will do that calculation down here and convert it to meters also. So equal sign, open some brackets, big value minus the small value, close my brackets, divide by 100 to convert. The uncertainty, however, I'll need to use the addition-subtraction rule for propagating uncertainties here. So just to remind you, if the value looks like this, then the uncertainty looks like this. So square root, absolute uncertainty of one of the values squared plus absolute uncertainty of the other value squared. So let me type that in now. Equal sign, SQRT for a square root, open the brackets, and I want the uncertainty of one of these values squared, so caret symbol 2 to square it, plus the other absolute uncertainty, also squared, close the brackets on the square root, hit enter, and now I have calculated the uncertainty on the height. With one problem, I forgot to convert into meters, so let me do that now. I double click to go into that editing mode, put my cursor at the end, divide by 100, hit enter, and that looks a lot more sensible. Okay, so the next thing I'm going to show you is I'm going to begin calculating the accelerations and their uncertainties, which will be quite a bit more complicated. So I'm going to zoom in a little bit so you can see what I'm doing better. Okay, so the first thing we're going to calculate is the theoretical acceleration that we got using a free body diagram before subtracting off the friction. So the formula for that was g, the acceleration due to gravity, times h, the height of the track, divided by L, the length of the track. So let's type that in, equal sign, and then scrolling over and up, I've got g here, so I click on that, come back to my equation, times, and now I want the height of the track in meters, so I scroll over here a little bit, get the height in meters there, scroll back, divided by the length of the track, again in meters. Scroll over, get that value, scroll back, and now I can hit enter, and that's the acceleration. Now the uncertainty for this will be a little more complicated. The uncertainty looks like this. So just as a reminder, final answer times the square root, and inside the square root, it's a sum of the squares of the fractional uncertainties. So this is where the fact that we're calculating the fractional uncertainty on everything is going to pay off. So let's start typing this equation in now. So equal sign, and of course I've written it down here as GH over L, but this is just the final answer. So I'm just going to click this cell where I already calculated my final answer, and then immediately go times SQRT for the square root. So now we want the fractional uncertainty of H. So scrolling over a little bit, there's my fractional uncertainty for H right there. I already calculated it. Come back and caret 2 to square it, plus, and now I want the fractional uncertainty of L squared. So I scroll over, there's my fractional uncertainty of L, click on it, scroll back, it's filled in for me now, caret symbol 2 to square it, close the brackets on the square root, hit enter. There's my uncertainty. So again, I just want to point out that you can simplify things quite a bit if you use your final answer rather than typing in all of those things again, and you use the fractional uncertainties that you've got elsewhere on your spreadsheet. And making your calculation look visibly simpler is actually a wise move, because if you make a typo, it'll be easier to find later if you kept things looking as simple as possible. So that's the acceleration and its uncertainty for the free body diagram before we subtract off friction. So the next thing we'd do is we would calculate the acceleration minus the friction, and then we'd calculate our 3 other theoretical acceleration values that were determined using kinematics. And I'm going to leave these 4 for you to complete. So you go back to the calculations you did last week for the uncertainties, and you would fill them in here and have Excel calculate your final answers for you.